There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is Mike Kistler, a principal program manager at Microsoft and one of the core maintainers of the official MCP C SDK. Before joining Microsoft, Mike spent time at IBM developing his deep expertise in REST APIs and HTTP, and he's carried that background into his current work in .NET on things like SignalR, OpenAPI, and the Model Context Protocol SDKs. In this episode, Mike and I dig into what .NET developers need to know about MCP, what it is, what features the SDK gives you, and what's in the 1.0 release. If you've been wanting to learn more about implementing MCP servers or clients in .NET, you won't want to miss this conversation with Mike. Mike, welcome to the podcast.
Hi, Jay. Thanks for having me. Great to be here.
Yeah, really great to have you. I'm excited to be recording this at the time we're recording this. The official version 1.0 of the the MCP C SDK. Let me get those words in the right order. Just was released. I think it was a week and a half ago, something like that.
A couple weeks ago, yeah.
Yeah.
I mean, when your listeners are hearing this, it will be a month ago, but yeah.
That's right. Yeah, because this will be coming out in April. So I'm sure everybody in our industry has at least heard the acronym MCP now, but I'm sure there's a lot of us that are still kind of just getting really quiet when that comes up, hoping that no one will ask us if we know what that means. So can you do the elevator pitch? What is MCP? Jay here. Just a quick break in the conversation to share how Trailhead can help you tackle your toughest business challenges. When you're navigating uncharted technology terrain, Trailhead creates custom software solutions that put you back on the path to success. Ready for the next step? Get started with an expert consultation at trailheadtechnology.com/offer. That's trailheadtechnology.com/offer. Now back to the conversation.
Sure. So Model Context Protocol. This is a protocol that was originally developed by Anthropic, released late in 2024. And then we jumped on board in 2025, and a lot of people started, to pick up on it and implement it. It's a way for tools and resources and other aspects to be provided to LLMs, language models, in an AI application. So it's just sort of a standardized way of saying, hey, LLM, here's some things that you might want to use, or here's some data that you might want to incorporate as you're handling the prompt from the user.
Mm-hmm. So I think of it as kind of a way to be able to give your LLMs access to other systems, whether that's like APIs or file systems or databases or whatever. Yep. Is that a good way to think about it?
That is a way to think about it. Certainly the tools aspect, LLMs traditionally can process data, but can't act on things. And tools are a way to give them the ability to act, give them the ability to, actually impact the outside world. Yeah. It used to be that MCP was also important to give current data to LLMs, which had been trained, up until a particular point, but then didn't know anything after that. Mm-hmm. That's become less important because now most LLMs will just go and search the web for you anyway and find all this information. So you don't necessarily have to point them at that anymore. So it is more about the actions, the performing those actions part now.
Yeah, that's a great example too, because depending on how it's implemented, that you could think of the ability to search the web. That's basically a tool that's been given to the LLM. It might not be an MCP tool, but it is a tool.
Right.
That those have. Okay. Great. So the implementation for this for .NET C# developers, as I mentioned before, it's the MCP C# SDK, rolls right off the tongue, right? But this originally actually came from a open source community project. Is that
It
right?
did. It did. I mean, when we started looking at this, we thought, do we want to do this? Do we not want to do this? And by the time we said, oh yeah, we want to do this, there were already a couple of implementations that people had built. And so we looked at those, and one of them in particular, from Peter Peterson, looked like, wow, this guy knows what's going on here, and he's really built a nice, foundation. So we contacted him. We said, hey, we'd like to, make this the seed for the official MCP C# SDK that we're going to be building. And he was very gracious and said, yeah, let's do it. And he has been involved since then as well, very active. So so it grew out of the community, but now has become the official SDK. It's sort of owned by Anthropic, but all of the people that are the key maintainers are at Microsoft.
Oh, that's cool. I love open source community projects. I'm on the .NET Foundation board. I know a lot of people have sort of, let's say, mixed feelings when a project moves from the community into a corporation, but I feel like at the foundation, we call that graduating. That's really just, it's a different phase for that project where it needs more work, more support, more effort.
Right.
And we love it when that happens because it means that people are actually using something that got created by the community originally.
Right. And that's why we wanted to, first talk to the maintainer, right? The originator of the open source project, make sure that he was okay with it. I mean, we didn't want to take something from somebody if they were, felt like it was theirs and they wanted to keep it. But I think, Peter realized that, it helped to have sort of the muscle of Microsoft behind this, and it would just make it that much better. So
and I'm sure in the over a year since that all took place, that there's been a lot of time and effort poured into adding additional things that Peter or the community might have not been able to support.
Right. Yep.
That's great. Okay, so I'm really interested in asking you one question because you kind of live in multiple worlds. One of them that you live in is the .NET creation of APIs and things like the OpenAPI standard, formerly known as Swagger. A lot of people still refer to it as. And I think when people first come to understand what an MCP server is, that there's kind of instantaneously a lot of confusion among developers about isn't this what OpenAPI is supposed to do? Basically defining the inputs, outputs, and functionality of a web-based endpoint. So since you're kind of in both these worlds now, MCP and OpenAPI, how do you think about these two, where they overlap, where they compete, where they're different from each other?
Yeah. So as I said before we started recording, this is one of the things that really made me excited about MCP. Was I saw that there was this parallel. I mean, the first thing that came to my mind was, wow, there's so many services out there that have OpenAPI specs today. I could take any one of those and very quickly spin up an MCP server that talked to whatever endpoints that I wanted to from that server, right? You could see the translation very, very easily. OpenAPI started 15 years ago, and it was, a different world then where you had to be very precise about how things worked. And there's all kinds of, the OpenAPI is a structured document that has all these different fields in it, and it's just getting more and more complicated as we go on. MCP is kind of like the OpenAPI for LLMs. A lot of the things, as a matter of fact, I just read a blog post the other day where they were talking about studying whether the input schema, if you put details in the input schema like enums and limits on you can put max and min values on fields and things like that, whether that improved the behavior of the LLM in in using the API. And what they found was that you could do that, but you could just put that in the description. And because the LLM knows English, it can just read the description, and it doesn't need all those structured fields, of the enum and all that kind of stuff. And it works just as well, and in some cases better than using the structured fields. So MCP is in one way the OpenAPI for LLMs, right? It doesn't need all the structure. But the other thing to say is that you don't necessarily want an MCP that has all of those detailed operations of every OpenAPI service. And there's actually a companion spec to OpenAPI called Arazzo that explains that is a way of describing how you combine different methods, different operations of a service to accomplish some goal, right? So in many cases, one API on its own is not enough. You have to call multiple of them in order to accomplish a particular task. And Arazzo describes that. And Arazzo is actually a much closer match to what you think of in MCP, where MCP is actually doing multiple of these things, a whole task at a time for you. So that's the way I think about it.
Yeah. Another way to think about it is that if you build a back end and a front end, maybe you're going to want the open API there, because the front end is going to probably be calling all the APIs that you created, but otherwise, why did you create them, right? But you might create a subset of those, or you might combine some of those into, like you said, more beginning to end tasks.
Yep.
When you're exposing those to an LLM.
Yep.
So it's not going to be necessarily one-to-one. Like, you're not going to have 20 API endpoints and 20 MCP endpoints necessarily in the same application. Is that right? Yeah. Okay. So speaking of the spec, you were talking about the MCP specification that originally came from Anthropic. A lot of developers, engineers are known for looking at something like that spec and saying, I could do that, right? We're known for wanting to roll our own solutions to things. So if you heard a developer, a .NET C# developer thinking about doing that, like, what does the SDK give them out of the box that's going to be harder than they think it's going to be to implement?
Oh my. Well, first of all, right now the MCP protocol is built on top of JSON RPC. And JSON RPC isn't that difficult, but it does have some quirks in it. Okay. And so you have to be able to keep track of IDs that you've issued and then match them to the IDs of responses that come across. You want to make sure that you're not responding to notifications and things like that. So the SDK takes care of all that for you. The streamable HTTP transport, the one that's the remote transport, has even more complications to it, in the sense that it uses SSE streams as a way of sort of being a back channel from the server to the client, sending information back, not just responses, but also requests. The server can make requests of the client, and those can flow back on that SSE stream. And that can get to be pretty complicated. SSE has a lot of little details that are hard to get right, or just are underspecified, really. And we've sort of come to a place where we have made peace with how we want to do it in MCP. So those are the kinds of things that the SDK handles.
Okay. You didn't really mention security, but that's another thing that a real application needs, right?
Absolutely. Yeah. So there's a lot of details about security, and there is a compliance test suite for MCP that all of the SDKs have to run, and the tier 1 SDKs all have to pass. And it goes into a lot of the details about those authentication and authorization features that have been built into MCP. And there are a bunch of people who are very active in this sort of the security space. People from like Okta that are participating, that are trying to make sure that we do the right things, that we've got our bases covered on security. So that's all goodness.
Nice.
And you're right. That's another key piece of what the SDKs will give you.
Yeah. That's a thing that developers love to forget about early on in the process, right?
Yes.
Look, I made it work, and then, oh, how do I secure this at an enterprise grade? Right?
Yes.
Okay, so without showing code, obviously this is more of an auditory medium, but what does it look like to get started with the MCP C SDK? Somebody who hasn't used it before, how much ceremony is there? Maybe I just want to take an endpoint that I already have and expose that as an MCP endpoint. What do I have to do that?
So there's the local case when you're doing an MCP server that's going to run locally, and then there's the remote case that kind of was what you were alluding to.
Yeah.
They're a little bit different. In the local case, you actually start your MCP server as a child process of whatever app that you're running, and you talk to it over standard in and standard out named pipes. That's pretty straightforward. It's just defining your MCP server with there's an extension method on the host builder, I think, that says add MCP, and you can give it some options about how the transport works. And then you define what your tools are, what your resources are, what your prompts are, and the SDK just handles all of the protocol messages underneath to wire that up.
Mm-hmm.
If you're doing a remote server, it's similar, but now it's on the web application builder, and you're pulling in ASP.NET Core. So it's built on top of ASP.NET Core. There's an extension method on the web application builder. You probably want to define your security schemes and authorization schemes in that as well. And there's a way to do that in the transport configuration. And then again, it's just define the tools, and you can add the tools into that definition by saying with tools, and then you name the class that has your tools in it. You can also say with tools from assembly. The thing about that I sort of shy people away from is that that uses reflection, so it's not AOT compatible. And you might not want AOT today, but you might want it in the future. And best to just not go down that road if you can avoid it. If you're starting something new, which if it's an MCP server, it probably is. Keep yourself to the APIs that will get you that AOT native when you're ready for it.
Yeah, that's definitely, for performance reasons, going to be great to have that option. If I can self-promote a little bit, late last year at .NET Conf, I did a talk about how to take a ASP.NET Core API, REST API that you already have, and expose parts of that as you choose with MCP. So I think that's probably a pretty good way. Now, that was before version 1.0, so there might have been a few SDK changes.
There have been a number of SDK changes actually, and leading up to the 1.0 release, we were sort of furiously trying to find things that because .NET has such a history of avoiding breaking changes once we get to a stable API. We said, let's just try to find anything that we think is going to cause us pain later. Break it now before we get to 1.0.
Yeah. Yep.
So yeah, there have been a few.
That's definitely the risk of using anything that's a 0-point release, right?
Yeah. Yep.
There's always, in a big organization like Microsoft, there end up being competing ways to do the same thing, right? So if you're a .NET developer used to ASP.NET Core, probably the MCP C SDK is going to be a great option for you, especially if you've got existing web applications with APIs and things that you want to MCPify. Is that a word? There are other options though, right? If you're doing Azure Functions, there's an MCP extension that you can use for that. You can put any web application behind Azure API management and do MCP endpoints on top of them. How do you think about these different approaches? I may be missing some as well, but how do you think about these different approaches all from Microsoft, and when do you use each one of these?
Yeah, that's a good question. The functions case would have to be, I think, sort of the simpler case of when you were just trying to provide data or provide very simple actions. The cases that we see most are cases that don't fit that mold. They need, you know, a little bit more heft in the back end in order to accomplish what it is that their tools provide or their resources provide. Yeah. As far as the API management piece, I think the API management is just layering on top of an API, which, you know, we talked about earlier, might not be exactly the right fit. I mean, it can work, and when you need to put something up quickly, yeah, sure, go for that. But I think you want to be you want to eventually sort of know what it is that are the key scenarios for users, and then craft them into an actual MCP server.
Yeah, I think that's really helpful advice. So if you're already building Azure Functions anyway, doing something simple, stateless, you're going to want to maybe consider using the extensions for that. If you're already using API management to wrap around your APIs, that's a simple approach to get some MCP endpoints live. But like you said, maybe not robust in the sense that you might want to call the code for 3 different endpoints when you're doing some LLM-oriented task, right? Right. And now the LLM has to orchestrate all of that. It might not do it right every time or whatever. Okay. And so then you've got the sort of power tool, and that's the MCP C SDK.
Right.
Got it. So we've been talking a lot about creating your own MCP servers with the SDK. It also has a whole other side that is about creating MCP clients. I feel like that's probably slightly less frequently used, but can you talk a little bit about what that is and maybe like a scenario for someone who hasn't even thought about what they would want to use that for? What that would be useful for?
Sure. And I think you're right. That is less frequently used. And that's sort of the philosophy of MCP is that you want it to be cheap to create servers and easy to create servers. And then the clients are generally going to be more involved. You know, it require more sophisticated development, things like that. But I've written a bunch of clients. You know, a lot of times we'll have new features that have support on both the server and the client in order to make them work. And so when I test them out, create demos for them, I need to create the client side. So you can create simple clients. For example, most of my clients are just console apps, right? And they accept input from the console. They attach to an LLM. They can pass things to the LLM and then turn around and pass, you know, call the MCP server with things. But it's just a client protocol that will get you set up connected to an MCP server. And the architecture of MCP, people use these terms a little loosely, but basically a client is intended to be the connection to a single MCP server. So if you have maybe an application where you have 3 different MCP servers that you're talking to, that would kind of be 3 clients with one, what they call an MCP host. The MCP host is like the AI application that's doing all of the coordination, talking to the LLM, things like that. And then it has clients that talk to servers.
So often you just give a list of MCP servers and authentication credentials to an LLM directly, and it calls them itself. Would it be fair to say that these clients are best for when you want to have some deterministic code that's doing that orchestration?
Well, the client part of it is really just implementing the protocol, right? The client, at least that's the way I think of it, right? Is you have this JSON RPC protocol where you have to form up the messages and send them across and things like that. And the MCP C SDK, for example, just exposes C# methods that correspond to, I'm going to call a tool, or I'm going to access a resource or whatever, right?
Got it.
And then the host is the thing. So in a lot of cases, there's some user consent that is required for this communication to go on. One of the fundamental principles of MCP is that the user is involved in and gives consent to any data flow that's going from the LLM to the MCP or from the MCP to the LLM. And this is part of, trying to ensure that things are done securely and that there's no data leaks and things like that. Yeah. So the host actually provides a lot of that functionality, right? It sees that the LLM wants to make a tool call, and it first gets consent from the user and says, is this okay? And then it uses the client to go and perform that tool call.
Got it. Okay. That definitely clears that up. Another cool feature that I know is added in the version 1.0 release of this SDK is support for something called elicitation, which is specified in the MCP spec. Can you talk about how that works? Maybe give an example of what that might look like in a real world scenario.
So elicitation is just a facility for an MCP server, probably a tool call, although it could be something else, to come back to the user and say, you wanted me to perform this function to run a tool, but I need a little bit more information than you originally provided me. And this is a way, sometimes the tool call doesn't have, you can have a set of parameters, but then when you look at those parameters, you realize, oh, there's some other piece of information that I needed in order to really complete what the tool call function was. And so elicitation is a way of coming back to the user. And this is an example of one of those server to client requests. Okay. The server makes a request to the client, which then passes it to the host and says, hey, I need this additional piece of information. That could be just, data about, what they were asking about. But there's also the potential that it could be things like credentials to access a backend system, right? And there's actually a special flavor of elicitation that's called URL mode elicitation that lets that flow work, because what you want is those credentials not to actually pass back through the client, but go from the user directly to the MCP server so that there's no chance of leaking them, right? And so URL mode says, I want you to provide this information, but do it by loading this URL so that you can get to the page where you can pass it directly to the MCP server.
That's pretty cool. So the go between, the LLM in between, doesn't really ever even see that information. Right. There's no chance of it leaking.
That's right. Yep.
Another kind of related, I think, feature is the support for long running requests.
Yes.
So HTTP has this, built-in timeout capability, and in some cases that doesn't work great for this type of remote code calling. Can you talk a little bit about how that works and maybe give an example of a scenario where you'd want it?
Yep. This is one of my favorite features, actually, in the most recent version of the SDK, because when you're running locally, you can execute a tool call, and that tool call could take 30 minutes, an hour, as long as it needs, because it's just going to flow that information back in the pipe when it's done. But as you said, when you have a TCP connection that's flowing over, there are timeouts for those connections. You don't want those connections to be long running anyway because of resource consumption and things like that. So there's a new feature where the server can say, I'm going to get back to you, but for now we're going to close this connection, and later you can come ask me about it and I'll give you the response. And this is done with, I mentioned the SSE stream earlier and some of the, details, the nitty-gritty details about how that works. This is actually a feature from SSE that MCP has sort of borrowed for this purpose, is a way of saying, I want to resume the SSE stream, at this particular ID, and then that reestablishes the stream that lets you send back the response when it's actually ready to be sent. So now you can have an HTTP a tool call over the HTTP transport, and it can take as long as needed. And I mean, these were always on the client non-blocking anyway. So the client would just sit there and, you could continue to do other things. And then when that's done, the client would realize, oh, that's done. Here's your tool call response.
Behind the scenes, I'm curious how that works. It reminds me of something like SignalR, which has levels of fallback that go from WebSockets all the way down to repeated long-running HTTP requests. Can you reveal a little bit like what's going on behind the scenes to make that all work?
Sure. By the way, I'm also the PM for SignalR.
I'm trying to mention all of your products today.
Very good. Very good. It doesn't have anything to do with WebSockets, although people have wanted to add a WebSocket transport to MCP. So far, it has not happened. But no, it's basically this SSE stream where you send back events in the SSE stream, and then if the connection is terminated, either by the client or by the server, or just because of a glitch in the network, right? The client can take the last ID that it got in one of those events and come back to the server. It would do this with the GET stream. When you send messages to the server, generally you're sending them with a post, but there's also a GET stream where you can say GET, and you can say, and I want to resume the stream with this ID, right? And then it says, oh, okay, that was for this tool call. I'll just start sending you the results for that tool call. And if the tool call hasn't finished yet, the server can respond and say, nope, I'm not done yet. Come back to me in a minute or an hour or whatever, right? Okay. And then the client will go sleep for a while and then send a new request. And then when it's done, it will just provide the response.
Oh, that's cool. It's fun to understand those things a little better, the way that we have gotten around some of the statelessness of the web for more stateful type experiences. That's great.
Yep.
So you mentioned security earlier. This is obviously a super important topic, particularly when you're talking about using these in the real world and enterprises. And MCP maybe doesn't have the world's greatest reputation when it comes to security, but I think that this SDK and other SDKs like it are working very hard to add that layer of security, provide you stuff like OAuth implementations, and make this like production ready. Can you talk a little bit about the efforts that have gone into security in this SDK?
Sure. So the security has involved basically in every release of the spec. Originally, it was, we're going to do OAuth, but the authentication server and the resource server wound up being smashed together in kind of a strange way. So in the 06/26 version of the spec, I believe, those were separated, which is a much more standard approach to the way security is implemented for regular HTTP services. Is you go someplace and you get an OAuth token, right, and then you send it in the bearer to the resource server. That's how it was in the 06/26 version of the spec. But there were some additional features like dynamic client registration, which is often the case that there's no pre-registration of the client with an MCP server. They don't know each other initially, so there has to be some way of them sort of getting to know one another, how they work, what their callback URLs are, all that kind of stuff, right? Dynamic client registration turned out to have some problems. And so in the 11.25 version of the spec, there was a new flavor introduced called client identification metadata, CIMD documents. Okay. So this is a way, again, for the client to come along and say, to the authentication server, here's who I am. here's how you can work with me. Please issue tokens so that the resource server, will know who I am. And so we've evolved to that. Now all the clients, SDKs that support the new version of the spec, support that as well. And a lot of the authorization servers are coming along with support for that. Another thing to say about security is in the newer version of the spec. Sorry, did you have a question there?
No, go ahead.
Okay. There was a neat feature about what did they call it? It's basically progressive scope enforcement. Okay. Initially in the 0626 version of the spec, you pointed at an authentication server and said, these are the scopes that the resource server might require. And you listed all the scopes. That's not really a security best practice, because then, clients would go to the authentication server, say, I want all these scopes, even though it might not need them all. Right. And that's sort of over permissions. We want to enforce the principle of least privilege.
Yeah.
So we want to start by saying, give the client the smallest amount of scopes that it needs to do the basic things. And then when it needs more, it can go and ask for more. And then if it's authorized to get those additional scopes, it will, and then things will progress. So that progressive scope is something that we've implemented in the 1.0 version of the SDK, and all the tier 1 SDKs are implementing it as well. And so now the server can have different scopes for different tools based on what permissions you want to give to users and how you want to grant those permissions. And that's a very nice new security feature in the 1.0 version of the spec.
Yeah, that sounds amazing. So I'm assuming from what you just described that there's a way for each MCP server to communicate with the LLM what version of the spec it implements, since there's some of these breaking changes over time.
Yeah. So that's always been part of the initialization handshake, where the client says, this is the version of the spec that I want to talk. And the server, if it accepts that version, will respond and say, okay, let's talk that version. If it doesn't talk that version, or maybe if it wants to try and move up, it'll say, no, let's talk this version of the spec. And there's this negotiation that goes back and forth. And eventually they settle on, it's this version of the spec, this version of the protocol that we're going to talk over this connection. And then everything is governed by that.
Sounds similar to the initial steps of the HTTPS.
Yeah, probably. Yeah.
Okay, interesting. I want to talk a little bit about governance too with you. So obviously Anthropic is where this originally came from, MCPs. But it's my understanding that there is a steering committee and that Microsoft has a seat on that. Can you talk a little bit about that and what Microsoft's role is?
Sure. And not only that, but recently the whole sort of governance of the project moved to the Linux Foundation. So now it's a Linux Foundation project. That sort of gives us a little bit more independence from Anthropic, even though there are still many people from Anthropic on the steering committee and, participating in things like that. But, this has evolved over time. I mean, when we originally started, there was a Discord server, and it's like, well, if you want a person in the Discord, we can maybe add one person in the Discord. We added one person in the Discord, and then, a few more got added. And then eventually they realized, oh, we need to have a public Discord server. And so now there's a public Discord server. Anybody can join. Anybody can, listen in on the conversations there. And then they formalized the sort of the governance structure where there's a set of core maintainers that a small set, and there is one Microsoft representative on there that vote on, okay, these are the changes that we want to have to the spec. We formalized the actual proposal process. They're called SEPs. This is, I think, sort of the tip of the hat to Python's PEPs. But these are spec enhancement proposals. And so people submit a spec enhancement proposal in the form of a PR that describes what the proposal is. And then there are also working groups where a lot of the details of these enhancement proposals are hashed out. They get early feedback from the working groups, and then they go to the core maintainers, and the core maintainers sometimes come back and ask for changes, or will vote to accept. So and the whole governance process now is very well documented out on the website, so people can go and read that and understand how it works, how to get involved. It's really evolved from the early days.
Yeah, it sounds like it. I saw an interview with you. It might have been much earlier on, before the Linux Foundation or any of that was involved, where you talked about Anthropic sometimes can change the spec in ways that aren't technically breaking the spec, but change some of your C# interface level implementation. Is that something that has improved then with some of these changes?
I think all of the core maintainers are very keen to avoid breaking changes to the best extent possible, including breaking changes in the SDKs. And I think maybe they've become a little bit more attuned to that now. It is still the case that the Python and TypeScript SDKs are a little bit more resilient to some of these changes than the C# SDK, which is very strongly typed, right? And in the way C# developers expect. But I think we have a set of core maintainers that understand that and want to help avoid those breaking changes.
Well, I suppose software always goes through different phases of life, and the early phases of a new technology's life usually is very frenetic, lots of breaking changes. So you guys were smart, maybe using a 0 version number for a while, knowing that was going to be the case. Here we are now, a little over a year later, and you guys have released 1.0. I'm curious, what made the decision for you guys that this was the 1.0 as opposed to a past or future version?
Well, to a certain extent, we had to move to 1.0 to be classified as a tier 1 SDK. And we felt it was very important to be a tier 1 SDK. So that, in truth, drove a bunch of the thinking. But also, people want to use stable releases. I mean, we certainly appreciate that. And so we felt it was important for our users too, even without the sort of the driving point from the tiering system, to get to a stable release. We just weren't sure. We needed to feel comfortable that there was an understanding within the core maintainers that this was going to be a big commitment for us, right? More so, I mean, in a lot of the other language ecosystems, there's the sort of we just declare a new major release and all is good, right? In .NET, it's less so, right? Because we have these diamond dependency problems that we struggle with. So when we declare a stable version, we want it to be stable for a long time.
And not a long time in AI development terminology, like 3 or 4 days, but months to years.
Right. Yep.
That makes a lot of sense. So let's say someone's been listening to this conversation, an engineer, and they've gone now from kind of knowing what MCP is to understanding it hopefully a bit better, and now maybe they're salivating a little bit. They're a .NET C# developer and they want to jump in. Do you have any good resources, like getting started resources for them to look into?
So one resource that I haven't mentioned yet that I want to make sure I mention is that we do have a template for an MCP server You can, and the template has some parameters in it, so you can either create a standard IO MCP server or an HTTP MCP server from it. It's there right now. It's in a package. You have to install that package, and then the template becomes available. And you just say .NET New MCP server, I think, and you tell it whether you want to be HTTP or not. That's going to be moving into the SDK soon, and so it'll just come with the SDK, and you'll just have that template available. So starting with that, and then building out your tools. We've got a lot of resources on the Model Context Protocol. I think we actually have a vanity URL now, c#modelcontextprotocol.io, where the C# SDK is documented.
Nice.
And we've done a lot of work on that documentation. There's all of the API documentation that's put out. We're using DocFX, which is sort of a standard in the C# world, to get all of the API documentation out there. So all of the APIs are documented. But in addition, we have what we call conceptual docs, where we go through the different aspects. Here's how you build tools. Here's how you do sampling. Here's how you do elicitation. And there's sections for all of those. And it's roughly in the same organization as the MCP spec. So if you're looking at the MCP spec and you say, oh, that's a neat feature, you should be able to go over to the C# SDK documentation and find, the same section in roughly the same place, and be able to find out how you do it in C#.
Okay. And if someone's wanting to get started before that starter template gets added to the SDK, do you know where they can find it now currently?
There's a page in Learn where we describe it. It's it's just a build your first C# MCP server, and it goes through the steps. It'll tell you where the package is to install, and then everything is the same from there.
Okay. Yep. So if someone just searches for learn.microsoft.com and build your first C# MCP, they're going to find that.
Yep.
Okay. That's great. Last question I like to ask every guest that comes on the podcast. We've been talking today about MCP, and I've learned a lot, and I'm sure listeners have learned a lot. So thanks for that. But what other topics or what other guests do you think we should consider having on the podcast to talk about our general topic of making software projects more predictably successful?
Yeah. So as far as topics go, the thing that really jumps to my mind is having repeatable, dependable, shareable development environments across your development organization. And the way that I do this is with dev containers. So there's a way in VS Code where you can say, open this project in a dev container, and that will start a container. I use Docker Desktop, but I guess other things work too. It'll start that container. It'll load whatever, software tools that you have defined in there. So I always use the dev container for .NET, and it'll load the latest .NET SDK in there. You can add other tools like Node or Python if you need them. You can customize your environment with environment variables and all that kind of stuff. And then, you get loaded up in VS Code with a repeatable development environment. And if you store that dev container configuration in your repo, then other people on your team can do the same thing. And you wind up having the same environment, and you're working in the same way across your whole team. And these dev containers even work in code spaces. So you can point somebody at a repo on GitHub and say, just open this in the code space, and you'll be able to see how it works. And cool. I think this is a technology that really helps teams coordinate and be repeatable.
Yeah, I know there's Microsoft offerings in the cloud that do the same thing with VMs, but this is sort of a containerized and maybe more local way to do the same thing, which I think is a great option to have.
Yep.
So yeah, that's a great topic. Thanks for suggesting it.
Sure.
Well, I want to thank you for your time today, Mike, and for your expertise. This has been a really interesting conversation, and
Happy to be here,
really
Jay.
appreciate having you.
Yeah, thanks. It was great to be here. Thanks a lot.
That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one, with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.